invested, and we found that through systematic study, see important resource. However, to make it available resource or useful resource and commercial commodity, there must be some technological interventions requirement. That means we'll have to handle it properly, and we should have some provisions of technology so that this could be used as a resource. If this can be used as a resource, then the economy of this biogas, owning of biogas, will increase much higher, even at lower scale of farm level of biogas plant. I explained that how we have tested this different component is an experimental process that we did it, and this is an biogas plant we used for experimental purpose. Yes. Now next part, this is a very important findings we have found. Mostly in unconventional systems, villagers use cow dung. However, in industrial plant where they have in other countries, they use different feedstocks, including the crops, corn or other crops, stems. But in Indian context, mostly at small scale household, this cow dung is used. But there are many residues, many your crop residues and other biomasses which could be favorably used for production of this biogas. But what are the challenges? Challenges is that this biogas, this microbes works on this biomasses if it happen typical conditions. The conditions are determined in terms of their physical conditions, rheological conditions, because flow and other parameters are involved, its chemical characteristics, its sizes, all those things are there. Now, the co-digestion with any of them, with the cow dung, we have proved that it is useful. Its biogas productivity, that is biomethane potential, increased. But we will have to ensure that whatever the feedstocks fed to a typical biogas plant, it should have the quality feedstocks. Feedstock means raw material that we use, that biomass. And then a simple random mixing is not going to benefit. We need some of this technology first. Then second, the quality assessment by some tools, maybe some interventions that my colleague Syed and has already mentioned, some interventions where you could ensure that yes, this is the appropriate consistency that is required for this biogas plant. First, a technology for proper mixing, proper cutting, and then second, to ensure before feeding it to this plant. This is important, and that heterogeneity address could be addressed. We have seen by different type of microscopy of these materials, we found that yes, it has different level of the variations in their lignin content, variations of their other your cellulose and hemicellulose content, but a typical pre-treatment. Through a typical pre-treatment, it is possible to make a consistent feedstock which would be suitable for biogas productions, and thereby could maximize the biogas productions. Maximizing the biogas productions, economy will be in favor of these users. It requires some technology interventions where desert quality could be ensured. It is being taken care of this feedstock. Next, please. These photographs were done for this different type of things. Now, finally, out of this, whatever these things I am telling, that there are many other problems that biogas, though in numbers, there are many numbers. In numbers, if you find in statistics or in Government of Indian reporting or even reports of these schemes, you'll find the numbers are okay. This okay, but functioning biogas plants are very few. Even in it is not proper for me to quote for other states, or in Assam you will find that you will find even biogas plant installed very recent 2010, 11, 12, 13. There are biogas plants which are not being operated, but you hear also biogas plants which are being operated for 30 years. This particular biogas farmers, he has 30 years old plant, but some biogas plants are not working, and there are many reasons. And then it is by the farmers or the users, they do not know what is the problem. Is it the problem in this biogas tank digester? It's a problem with the feedstock. It's a problem with the inside the digester. It's a problem with the gas holder. Is it the problem in this even this burner? Some of the burners blocked. Is it the problem with the pipe? The problem identification is a problem. The agency which install provide the training, but the training also they are handicapped. They did not know. So this is one issue that to be taken care. Second, this quality aspect of this feedstock. quality aspect of the digester, this should also be known to them. And then feedstocks, and that there are many miscellaneous issues. Now we should try to have a solution, an app-based solution, smartphone-based solutions, where app itself will give, if he understands, if there are some sensors or some gadgets which will take care, which will understand. For example, already my group, my I think colleague here, some of the colleagues with whom I'm working, we are conceptualizing that. We are thinking that if some sensors are put inside the digester, which could give us the conditions of the temperature, which could give us the condition of the gas pH conditions, which will give us this gas productions, different species of the gas, and then that information will indirectly give us then indications. Same way, the doctor gets some indications of my stomach conditions, whether I need to take a tablet for gas or I did not. The same thing could be that your diagnostic is possible by some sensors. And then automatically, maybe some control, there is also an ambitious plan could be done, that if a temperature sensor, temperature is going down because it works with temperature of 30 degrees, temperature is now 25, some arrangement of thermal energy management is also possible, automatically taken care, or we can have some manual control. Similarly, pH can also be controlled, mixing can also be controlled. These are the interventions required so that a smart biogas reactor could be taken, will take care of its own problem, and then it's a luxury for the users rather than a headache for the users. I have just given a visual here, connecting that in mobile apps itself could give the solutions to all of them. And then these mobile apps can be an repair, maintenance, or service provider business. Some of these entrepreneurs could come for doing this business. Next, please. I'm really happy to introduce two of my colleagues, Akshay and Abhishek. I have been visiting. This is an bio-CNG production plant in Punjab, near Chandigarh. And we are working, collaborating with them now. They are now struggling and they are doing good business, but they feel also a similar thing. Earlier, whatever the presentations I have given so far was considering this household small-scale biogas plant. But biogas can also go to this industrial scale, they have proved. They use it with different feedstocks, and then there are also problems. The profitability could be enhanced if some technological interventions could be introduced over here. And they are producing gas as well as organic fertilizers, and more or less they are here. Maybe some of this direct input we could get from them. And then technological interventions in terms of the sensors, in terms of these automations, in terms of this data transfer can improve their functioning and then increase this business better. Next, please. We could say that, just to conclude here, this residue which remains unutilized, which is the methane, because it is unutilized means after fulfilling the organic carbon requirement of the soil, whatever is left in the field, this is, even if it is not burned, it could create lots of problem of greenhouse gas emissions. Under the rainfall conditions, and when it goes anaerobic, then it will produce, and there is a lost methane, and this global warming potentials of methane is much higher than its carbon dioxide. So it is a very urgent issue to address it. And then we found that in India, around 200, I'm safely say that 200 million ton of this crop residue could be easily used out of the 686 million tons of the 28 states. We made an assessment survey all over this India through these different parameters available on these crop productions. And then bioenergy, finished. Last slide, I think.
Yeah, fine. Yeah, okay.
It's going to be, I think, last slide. Next, please. Next, please. And this is concept I actually prepared to give, that multi-crop residue is an issue. We can take care of these different characteristics of different residues. There is an challenge now, but technological interventions can convert them challenge, and then that could be a resource. Multiple crop residue also address the issues of availability at different seasons. We can have the different one. We can take care of this issue. We have some pre-treatment technology, and then again quality ensuring technology, and then finally some of this technology intervene. I have shown, I don't know whether it is proper or not, some of the technology intervenes biogas plant, and finally all will be taken care by this your technology what Syed and other groups members are telling now. And finally, here also some ambitious plan of us that this biogas, if we need to a bottle transportable CNG, then carbon dioxide to be separated, and then fertilizer to be separated. So we'll have 3 products, and dry ice, carbon dioxide, the biofertilizers, and bio CNG. And if this goes with us, and another thing, though I mentioned the reactor itself, there are different reactors now coming at different level. Your plastic reactors, reinforced reactors. Yes, reactor design is also some gap is there. There is also possibility of some interventions, technological interventions. The smart reactor as good as a washing machine. Why I need to rely on all those problems by your masons, then difficulties. There are many practical or engineering difficulties of then good reactors. So maybe material science improvement and that our desired requirement could lead to an development of a good reactor as good as a washing machine, as good as our refrigerator. That could be possible. That's a dream over here. So with this, I thank you all. This is, I think, last slide. Please. Next, please. Thank you.
Thank you. Thank you, Dr. Barua. It was very interesting topic on biogas, which I have not worked in biogas much, but I think where you can apply for technology, what you're saying makes some sense. Like you took us from a village to a big commercial production level, it needs technology. That's what we understand from your talk. Now, I will put on the floor for any question and answer anybody has. You can raise the hand because I cannot see all of the people on the screen. You can raise the hand. If you're, you can put on the, Dr. Narendra Shah, first raise the hand, I can see him. So can you ask the question, please?
Yeah, Dr. Barua, two sort of, issues that I would like to having seen 5 years back in Maharashtra, for example, at 2 places, they had put some 8-meter cube biogas digesters, and one had to stop because there was no adequate water. So if we can develop a technology where, for example, half the requirement of the gas, like water, for example, 1 kilogram of dung requires 1 liter of water. If there can be some process, biochemical process by which you have a dry fermentation, that is one question. And second, biogas digester just completely failed because there was no adequate dung. So what the recommendation came was like, install a food processing or a fruit processing plant next to the biogas digester. So it becomes very, very, suggestions or recommendations from the committees that, you have a biogas digester, now you bring a fruit processing or food processing plant. So do these 2 comments, if you can kindly address.
Thank you. Shall I respond it very quickly?
Yeah, please. You have to.
Very quickly, I'm responding. Yes, in fact, these problems are visualized while preparing these presentations. One is that water requirement. What we said that separation of this water, and then this water could be now presently in conventional systems, it is being not used. But if we could separate these waters, it is recirculated, this is become more effective because it contains enough. Then additional requirement of water will be much reduced, number 1. Number 2, there are now technologies of dry decomposition or dry degradations, and where water requirement is much lesser. In next questions, yes, we should not, it is very difficult to rely only a single feedstock like cow dung. That's why I am saying, I'm advocating here in my presentations, the multi-crop residue or any organic matters, for that matter, which is suitable. And then these technological interventions could help me to convert any damn matters which is decomposable to convert into an suitable feedstocks for raw materials for biogas plant. Thank you, sir.
Thank you. I want to call on Mohanty. Mr. Mohanty, you have a question? You raised your hand. Can you ask your question now? Mr. Mohanty? Setu, can you enable other 3 people also? Mr. Vengaya? Can you ask your question, please? You have to unmute yourself, Mr. Vengaya. Mr. Mukesh Kumar, you can ask your question. You can unmute yourself. Naresh Prasad Singh, you can unmute yourself, ask your question. Any of the four? If you can hear me, you can unmute. All of you allowed to talk.
Eji Baba. Eji. Baba.
Hello, sir.
Who is
I
that?
am audible. Mukesh Kumar, sir.
Who is that, please?
Hello.
Just speak.
Mukesh Kumar. I am audible.
One person. Mukesh.
Sir,
First speak, Mukesh. Others
okay,
don't
sir.
speak. Mukesh, you speak first. Mukesh first.
Yes, sir. Thank you, sir. I am about biogas production in home level for how much price and first time and place required for first time allotted biogas production at home level, sir.
Can I speak?
Yeah, please.
This is Lalit Maheshwari from Bombay. Bharat Kisan Sangh had done at Rajkot bottling plant for biogas, and even Kanpur Gausala tried bottling the biogas to supply across. So somebody should be able to share all the information across happening in the country. Maybe we can make it viable.
Good. Thank you. Mahendra Kumar. Naresh Prasad. Okay. Now I have. Okay. Anybody? Naresh Prasad, you want to speak? Okay. Setu, block all of them. Robesh Maity, you have a question? You can ask. Robesh?
So, Dr. Barua, you said that some of the places the plants are not working. So it's purely the technology or the commercial viability. So question is not about asking that question. Question is, can you give some picture about the finances and commercial viability very briefly, how the input costs are and how it is charged?
Yeah. Those your failure cases I am quoting, mentioning about this rural the plants which were installed under the schemes, different schemes of the rural development, different schemes of the government of India's forest department schemes or government of India schemes. And now here around 2 meter cube plant costing around 30,000, and then there are provision of subsidy, there are provisions of subsidies for material subsidy and these things. I think eco-financial is one issue. If it is given by that your government sides, then there is no issue, they could do it, and even they need it. But here, after providing this financial support, then also it is failed. The failures are from our study, I have at least surveyed around 60 plants. The failure reasons are different. Sometimes the civil engineering failure, sometimes the biological failures, and some of the neglected attitude, anything they put it in this your biogas plant. And then understanding well that this is a biological system. So these are different type of failures. Yes. As far as the financial viability is concerned, my friends Akshay and Abhishek is there. They could quote even the colleague saying about this Gujarat case. Yes, financially it is much viable. There are provisions of subsidies also under MN area also. If we compare the unsubsidized LPG, and then we consider other cases of remoteness also, it's obviously viable. And then Akshay and Abhishek, their source facility and then BioCity that plant in Panchkula has proved. I have even seen their plant. It is much viable. Abhishek is here. I think I request Abhishek to just answer these questions. It will be better from to Abhishek.
No, I think we should because time is very short. I think we'll have it for the next session. We have the
Thank you.
Taken out the question.
Thank you.
I think I would next. We have one more. Yeah, 1 second. Indramani wants to speak something, please. Dr. Indramani.
Dr. Barua. Dr. Barua.
Yes, please.
The aim of this seminar is to find out technological gaps, because in one of the slides in one of the slides, you mentioned.
Sorry, sound is not coming.
Not coming.
Okay, I'll.
No, it's coming.
Many we are able
Coming.
to hear you. I am able to hear you well. Like.
Okay, okay.
Okay, my submission is that objective of this webinar is to find out
Audible? It's not audible.
what you said.
Okay,
Will you
okay. I
repeat,
will. I.
please?
We can hear Dr. Indramani very well.
Okay, I think we'll stop there. I think I understood Indramani. I will come back to that topic from Barua when he can speak.
So he mentioned about gaps, and that gap should come out in this webinar. That what should be done to make this viable, and what we should do to make it to spread. So these are two things which we wanted.
Okay, okay. We'll come back to that. When another discussion is there, that time we'll come back again to him. Barua will come back again. Now, very short, I will, because I want to show the flow of the whole thing, the webinar. Today we are running short, but then we'll go another 10 minutes more afterwards. Please forgive me today. But then still we are running short. So I want to show how the flow will be there for the next webinars also. Okay. So we'll have one session, short session called Know the Team. Because here we have opportunity. For example, today people know about Barua is working. Others we don't know. Everybody cannot be seen. So we taught it short. So 2 to 3 minutes. Another 3 persons here. I want them to introduce themselves, what they're doing. Time is given is 2 minutes to 3 minutes. Okay. I think Murthy, Dr. Murthy. Dr. Murthy?
Yes, I'm here.
Yeah.
So,
you can put your,
good evening, everyone. And my name is Ganti Murthy. I'm a professor here at IIT Indore. And the research areas that I have been working on are primarily focused on resilient agroecological systems. So essentially, I work all the way from the soil health to the food processing, and we work on a lot of systems analysis part. So we take a systems approach and to these systems. So we look at technical feasibility, economic viability, resource sustainability, environmentally impacts of different technologies and processes. And we have primarily worked on biofuels and bioproducts for a long time. And now we are moving into wastewater treatment technologies. And we have used IoT technologies. We have used a lot of sensors, development of sensors, and very advanced process control, so that we take the complexity of some of these processes, for example, the biogas digestion or the fermentation processes, and then shift them into these control systems so that the actual implementation of the controllers themselves are very simple. So that's what we have been trying to do, and then we have actually commercialized those products. And for example, a fermentation process control, we have commercialized that. We have developed a technology for treating the landfill leachate, where we actually recover metals and things like that. And before coming to IIT Indore, I was a professor at Oregon State University. Thank you.
Oh, thank you very much. Next, I would like to invite Dr. Narendra Shah. Please, can you tell something about yourself?
So this is particularly for our young friends. I want to sort of, in a given 3 minutes, I want to tell you a story about self. So as a young lad of 21 years old, I actually with a BTech degree in agricultural engineering, I landed at AIT Bangkok to do my master's. And post my MTech at AIT Bangkok, I worked in energy department at AIT for about 4 years. And but then I embarked on a PhD program in process engineering in France. And post PhD, I had a brief stint as a postdoc fellow with EEC ASEAN project on small scale energy generation in France. And after that brief stint as a postdoc, I returned back to joined a Center for Technology Alternatives of Rural Areas at IIT Bombay, and I'm still there. I'm stuck at IIT Bombay. I teach there and research in the areas of agro-industry, decentralized small-scale energy technology, and food processing and nutrition. And if time allows, I will try to prepare some talk as indicated by Dr. Syed on how sort of small-scale energy, for example, how we can use it beneficially in value addition in food and nutrition. And currently, actually, I am posted in AIT Bangkok as a visiting professor here. Thank you. I hope I finished my story in 3 minutes.
Yeah. I would like to now invite Dr. Hazarika, MK Hazarika. Dr. Hazarika, please.
Good evening to all. So I am Mukesh Kumar Hazarika, professor and former head from the Department of Food Engineering and Technology, Phase 2 University. Presently heading the Center of Innovation, Incubation and Entrepreneurship, and also jointly coordinating the Technology Enabling Center of the university. Of course, I started my career in Department of Agricultural Engineering to begin with at NARESH, followed by at Department of Agricultural Engineering at Assam University, Silchar. Of course, actually as an engineer, actually I find myself to be more of a what we can call as an integrator. Actually, some of my activities are jointly conducted with people from computer science or electronics or mechanical engineering or molecular biology. So at my personal level, actually, I am working on post-harvest handling of rice or food grains and fruit and vegetable of this region. And of course, to join this PAZ, actually, I was quite, it is a coincidence for me. Actually, I have been discussing this thing actually at our department because my affiliation is for food engineering department, and where the nutrition concept is quite talked about. But actually, what is coming up late is actually sustainable nutrition. Means actually where we should talk about means the nexus of food, energy, water, and overall sustainability. So actually that way, when actually I got to know about this initiative, so I am to be very interested for this one. And of course, overall goal actually, what I think that actually we should work for a larger goal like the food solution for the global population that may be coming in by 2050 or so. We can have a target. But actually, at the same time, actually, I was just seeing for agricultural engineering or in general for any classical engineering, that engineering knowledge system that actually would be, that is what is called a system approach that is being employed by this data science, where actually they see as a cause and effect in the form of more of a black box. So that may make actually for the students or for upcoming students that actually that engineering knowledge may not be that preferred, may not be of that preference typically for this, because actually it will be requiring lots of mathematical considerations, design considerations, all. However, actually, if you consider this innovative prospect, actually, see, understanding the engineering units as smaller units will be adding to the innovation for future technologies. So actually, presently, I am working on that aspect, that is actually integrating data science perspective, something. Actually, I'm learning data science, but at the same time, actually, I'm trying to do whatever is the classical or physics-based, engineering-based models, and then integrating them. Actually, that is a concept that has been done, what is called as a gray box model. And of course, in general, actually, I find myself associated to basically competency-based design of content and delivery of engineering and vocational education. And of course, I look forward for this series for effective deliberation, and where actually we can fulfill the concern of the masses. And of course, here actually what another aspect in respect to actually agriculture engineering, I should say that actually we have it as an advantage or as a challenge as well, that actually one of our stakeholders is always a farmer, actually who do not like to take this farming practice as an enterprise. So therefore, actually much of our innovation is motivated by sometimes these government policies. So therefore, actually we are not sure whether actually our innovation finally actually yields the benefit or means overall goal, meets the overall goal. And for our locational advantage, we have found that actually this one of the enterprises which work on in this line is basically tea industries. So probably that can be a good case study where actually we can say that actually agricultural engineering can give them a wholesome solution to them, and probably that can be beginning point. Of course, till that actually there has been some limitation that actually how they are opening up to us and all. But actually now we are at this university, we are starting that whether we can just go along with them and find some solutions, and that will be model for overall agricultural engineering-based enterprise. Thank you.
Thank you. Thank you, Dr. Hazarika. I think next time, this is the first time we are trying this. Next time, I think I would like the know the team people will tell about skill sets, what they have probably. Today we are running short of time. What skills they have, so others will know. For example, I know one of the persons knows C very well in the team of 3 out of the 3. C is excellent, he knows. So I think when you make the tag team, I think he can probably guide and mentor the people in that particular technical skills. Because some people have technical skills in a different areas. So I think next time we'll do that. But right now I'll show you another part for a few minutes only short. What is exactly the idea of this? Actually, today I'm going to take only 3 minutes on this, but it's going to be half an hour from the next one, 20 minutes, 25 minutes. I'm going to show after this presenter what the tag is going to discuss about it. Can you please put a slide, please? Today it will be delayed by another 5 minutes. I think let us bear with it today for special case. Now, for example, this is the slide we have seen, which Dr. Barua has shown. So now it looks simple. I think one thing we got reply, biogas, it is financially viable. That we come to know from him. This I asked also very first before came, is it financially viable or not? Then I asked him, what is the reason you're looking for technology here? And we had a webinar. I had a webinar with him, with team also, Dr. Barua's team completely. He's a Department of Electronics people, everything about team. Now the question is, he says, the problem is actually, there could be a problem of pH value. It may be acidic. So the people say, farmer says it's not working. That's all. So how to find out? So then we discuss about, I think this is a challenge actually. If you want to use it, because we don't use much sensors. The very first you see here, we will come back with the solutions of sensors, how to detect the gases. For example, he told already methane and CO2, this is the 2 available, and different type of sensors available. So our team will help to identify the sensors, and somebody has to test it. The whole thing is somebody has to test. Only one lab can test this particular sensor is useful for this, and it's enough for throughout India. We can use all this information. That is the idea of this tag team, what I'm thinking. For example, you have hydrogen also, alcohol, CO and methane sensors are very cheaply available sensors. So sensor is one thing. Then he's talking about another one sensor also, flow measurement sensor. Flow measurement sensor or mass volume measurement sensor also we have to identify. Flow means how much is going to put inside and how much gas comes outside. And he needs a switch to find out whether gas is flowing through a burner or not, for example. So the complete sensors, then as you see the picture, it's in the form. So you have sensor in different places. So you have to know how to network locally first. Okay. He says the temperature, the person standing on the top of the slide, you see optimum temperature and varying season. So you need a temperature sensor there somewhere, and that must communicate to some other place. So this whole networking, local networking is excellent topic for this. And plus you have next level, the data goes to server back again. So that again, the third level. So actually when you see the application, a lot of learning can be done in technology which comes. So we will discuss this in next season and all. We'll discuss in detail about this. Right now I stop with this in short of time, but I think next time we will take up this. We'll come and present to you for this particular case also, probably after a few weeks. When we make some models and something like that, we'll come and explain to you how we have solved this problem of this technology. Now, with these words, I would like to request some remarks from Professor Gajen Singh. If he can tell some words. Slide off, please. Setu. Professor Gajen Singh. Professor Gajen Singh is there? I think he's there.
Yeah.
We would like to have your comments and advice.
Well, I must congratulate Devin Barua for excellent presentation. My understanding of biogas, whatever I have followed, is that on the individual farmer units, for one reason or another, not technology regions, but mostly management region, feeding every day, cleaning up from time to time, taking out the way, that has been a problem. Can we develop an entrepreneur system, enterprise, which will work more as a community, serve a community rather than an individual unit, and provide like as a service provider, giving a pipe connection to some 20 houses or 30 houses or 40 houses, okay? Then this entrepreneur can collect the raw material. It's not a problem to get raw material. Is not a problem in village from cow dung and all that. Question is how to manage it. So I think if we can develop a simple project of coming out with different sizes of biogas plants to serve a small group, 20 families, 30 families, 50 families, whatever it is, I think that could be a very good start. I do not see a much future for individual units for an individual family. I think it's too much lack of attendance for few days. They go and visit go to a marriage party in a relatives, 4 days something, everything choked, dried up, and nobody wants to start. There are so many other things. Winter season is different problem. Summer has a water problem. So I think these neglect for one aspect results into complete failure of their system. So my suggestion will be to work as an enterprise, as a custom hiring type system, service provider type. And if somebody, if Dr. Barua and other IIT Delhi and CIA Bhopal, there's so many places where they, and IRI Indramani's group himself is very familiar with the villages and working with it. Come out with those models. So my suggestion will be look at those workable models. Thank you.
Thank you. Thank you. Actually, now I have a request to make to all of you. We were, for making a webinar successful, we require challenges. So we require challenges. You're facing challenges in every area, but it must be brought to us. Like one of the examples he told, because we are searching for examples, people who have to give us technical challenges, like I told you, only then we can help. Because I know a lot of areas in water everywhere can be used. We have talked about it in different forums already. I want really people who are working on the particular area. For example, this is energy. Now we have problems with solar pumping. I know very well. The solar pumping is a big problem. There's no data coming inside. It can help very much technology. So anybody working in solar pumping, for example, can come inside. Last time we had an example of solar refrigeration used. Dr. Indramani, one of the team members, showed that. So I want energy with that type of technology. What requirement is there, where they need our help or where the entrepreneurship can come into picture. Now, like I told you, next theme also I'll give you. Next topic is, we are talking about, I have given one theme topic, that is the myth and the truth. This will be one of the theme where you can give me the speaker's topic. What is the real myth? What is the real truth in different type of, in agriculture, what we are using, starting from drones, starting from whatever application, how we can streamline, how the people think now, how really can be implemented the technology. So this, we have one more thing, energy we have seen now. We told energy, anybody wants to talk on energy? Water is water, you can take water generally I'm calling. Very important, the water problem is very important. Why I'm saying technology is important is, I know some projects which are happening, again I'm repeating, happening even in Maharashtra, where we want to find out what are the intervention done by different projects, different stakeholders in water, in contour farming, everything. It cannot be validated by now. So we need the system to come up with picture, people to understand. So with this request, I request all of you to give support. So we will take care of the training and finding solutions. We have a good team will make, and we want more people to come in the tag team. Anybody else want to have suggestions? We will have, we can talk for another few moments. No problem.
Yes.
You raise your hand. Anybody can give it.
Tell
your name, please.
Just may only I thank you. Already we are taking project the community progress plan dashboard. third households now going forward. 2 cow dung used, and I request that if come together and help us. There are some issues I have not covered in this presentation, and this is through a DST seed sponsored program in a remote village, and hopefully this will work and give us more information how to go with this model of community biogas plants. Thank you, sir.
Thank you. Thank you. Another, anybody else? Anybody else has suggestions? Other topics, or how to get the other new topics? Anybody new topics suggest? Any theme you suggest? Anybody?
Excuse me, sir.
Yeah, please go ahead. Please go ahead.
Excuse me, sir. Am I audible?
Yeah, yeah.
Sir, my question is from biogas plant, so much of slurry is available. And in drip irrigation system, we are talking about fertigation. And also we are talking about organic farming. So we should develop some methodology so that this slurry can be used as fertigation and drip. So this is a future research, a tremendous scope is there with the biogas, with a link to drip fertigation. So this is my suggestion, but research has not been done, but this is a scope for future. Thank you, sir.
Excellent. Thank you. Excellent suggestion. I think anybody else want to comment? We have another 3 minutes. Anybody can comment? Anybody has suggestions? No problem. We can talk.
So I tend, Robesh here, I tend to agree with Dr. Gajendra, that, so of course, this group is trying to find a technology solution. So even if we provide, the whole system will not probably be successful there ultimately, because there are other elements. So I think this problem needs to be defined, called as an efficiency. And today it is an efficient overall modular efficient. And then we say when we put technology, so today it is running at 20%. And when we do provide a technology intervention, because there will be cost, but the efficiencies will go to 80 to 90% overall system, then probably one can make a sort of entrepreneurial model which attracts people, So, and also is a return for all the efforts and the cost that will be associated with the technology.
Okay. Thank you, Robesh.
Thank you, Robesh.
Can I come in? This is Narendra Shah here.
Yeah, please.
Yeah. So, like, the Ministry of Petroleum had come out with a scheme called Scheme Ujjwala, for example, by which, it had good and bad points. Like, it did sort of give the subsidized LPG cylinders even in forests, for example. So, see the flame that comes out of the biogas, which is as good or even as better as the LPG flame. So if for example, as a part of some 10% of the scheme Ujjwala can be diverted to biogas, I think it could make much more impact in terms of increasing its utilization in the village area. So somebody will have to sort of make this as entrepreneur, or somebody will have to take up and say that it works as good as LPGs. So let the 10% of the users which are sort of target beneficiaries of Ujjwala scheme, let them use the biogas, and mostly the rural areas.
Thank you. Dr. Indramani?
I just wanted to add that this is really a very important area still. And what Professor Singh said, that rather than at individual level, we should go at a decentralized but connected one. Farm where we can provide energy solution to, let's say, a village, a complete village, we can provide energy solution. The second thing I wanted to add, that is byproduct, this biogas slurry has a lot of importance, which my colleague told, and the research has been done on application part. Apart from increasing nutrient of the soil, it increases water holding capacity. And if you apply biogas slurry, you can reduce one irrigation, at least in major crop like wheat and others. You can decrease one irrigation, reduce one irrigation. So that will be other. So that byproduct has not been basically used or popularized to the extent it should be done. So these are the gaps which we will enlist that with respect to biogas, this slurry utilization in fertigation, particularly how it can be used in fertigation. Then what should be the commercial viable proportion of biogas production? That Professor Singh knows that we got a very big project. There was some problem. Otherwise, we had a to Japanese support. We had a proposal. It was approved, but finally it could not basically materialize. Whole area, we had a plan to find out energy solution. So, seeing the energy crisis, biogas stands a very good. It has to play a very good role. But all the technological hiccups and commercial and your business model, that all needs to be developed to make biogas a very important energy source. With this, I thank Dr. Barua for a very wonderful talk. And I'm really very happy, as Dr. Syed mentioned in the beginning, that Northeast, West, North and South, and whole India is together.
Plus US and Bangkok.
And Bangkok.
I'm in New York.
And
I'm very far away.
So this is what is another purpose of connecting people. And sir, we missed that one. We have many successful stories as one of our farmer friends shared that in Gujarat or in other parts where successful stories are there with at farmers level. At least one objective of this webinar will be to collect all these information at one place and find out what all is available at this country, in particularly in biogas area. So that again we will say, and I will request my farmer friends and whosoever are participating, please share the information little in detail so that we can compile that and put up at our ISAE website that what all is available in biogas area, research level, commercial utilization level, and then gaps, etc. We can collect all this information and put it at our website. That is what our peer group has been suggesting, that bring in all these technology at one place so that with one click a person can see what is available and what are the gaps. With this, from my side, I thank you all, and Professor Singh and today's speaker, and Dr. Syed, you have been part of the whole program. So, lot many thanks, and all Partha and Setu, Rauf and Dilip and all are working. Thank you very much for all your contribution. Thank you.
Thank you.
Thank you.
So we close down. Thank you. We close.